Hi, how are you?
I'm good. How are you?
I'm also doing good. Thank you.
Yes, Sushant. So, as we are here to discuss about your background and your tech skills for the position of machine learning and data scientist,
Mm-hmm.
would you like to introduce your about your career, what you have done right now, and everything?
Yeah, sure. Yeah, so my name is Sushant Menon. I did my master's in data science from Indiana University, Bloomington. Before that, I completed my bachelor's in electronics. I have been working in the data science and AI industry since the past more than 4 years now. I have worked in specifically Gen AI technology since the last 3 years. I have worked on a lot of different projects, including the most recent ones in Gen AI. But other than that, I have also worked in traditional ML projects such as time series analysis, regression analysis, classification problems, and things like that. I have worked on various different deep learning technologies as well, like CNNs, image labeling, and things like that. But yeah, and other than just the technologies, I have worked on different infrastructure frameworks such as Azure, AWS, and Google Vertex AI as well. Specifically, I have used the AWS SageMaker for my fine tuning projects, such as like fine tuning Code Llama 7 billion models. I have used Vertex AI Studio for fine tuning the Stable Diffusion version 1.5 model. And I have also used Azure AIML Studio as well as the Azure database as well, like Cosmos DB and things like that. So yeah, that's my a little bit about my background.
Sounds good. Your experience seems fantastic in the field of machine learning and data science. Would you like to explain me or take you through one of your best projects which you have worked recently,
Mm-hmm.
either in the field of generative AI or in the machine learning?
Yeah, yeah. So the last project that I worked on was a a multimodal system. So not just a simple rack, but more an advanced multimodal rack where we had not just text data but also image data and tables and things like that. So what we had to do was we had different kinds of files. So not just like .pdf. We had different file extension types as well, like pptx, ppt, html, and excel files, csv files. So we had a combination of all these different files, and we had to create a rack system out of that, right? So how do we do that? So what I did, and the documents did not just have text; it also had images, it had tables, it had formulas and things like that. So we had to create a rack system which would be able to recognize all of these different elements, not just the text data. So what I did was I first separate. Take an example of just one document. What I did was from one document I split all the different elements that the document had. Right. For example, we have text, we have images, we have tables, we have formulas. So what I separated all of these things using a third-party library called unstructured. So once we have that, what I decided to do was, so we have two methods that we can embed all these different kinds of elements, right? All these different kinds of data. So the one technique is to directly embed them. For example, for image, you can use an image embedding model and directly create a vector out of those and store it. But what I decided to do was convert all of these different elements into just one element format, that is textual based. So that means converting image into text as well. So how do I do that? So what I did was I used GPT-4 to describe the image in detail. So that gives me a textual description of what the image looks like. Similarly, with the tables, the formulas, everything. So the reason why I decided to do this was because I wanted to keep all my data in the same format, which makes it easier for retrieval, and it makes it improves the accuracy as well. To just keep the data in one format, and it is clean as well. So once I did that, I converted all my data into textual format, and then I used a text embedding model, ADA 002 specifically, to embed my documents and store into Azure AI Search. Yeah, so the infrastructure that we used for this project was Azure. Right, so that's why I embedded all the models and then dumped it into Azure AI Search. So then, whenever a user queries for any question, we just match it using semantic search with the available the data that I embedded. This includes tables, the images, the formulas, everything, and then we give the final response back to the user, right? And also we had to integrate multiple chats, so we had to store the chats as well in Cosmos DB inside Azure as well, and things like that. So yeah, that is my whole project.
So, where you are storing your image information, so assume that the page has the image. So you will first extract it using the unstructured. Then
Mm-hmm.
where you will store it and how you will retrieve it if assume any questions come up regarding that image.
Yeah, so as I mentioned, so the image is in textual format. Like I converted the image into textual format, right? For example, if there is an image of let's say a horse chewing a grass, so the GPT-4o model using that, I will get a description of the image, and it will just give me like the horse chewing a grass, right? And then I embed that text and then store it in Azure AI Search, and then also not just the embedding, but also I have the metadata option to save as well in the Azure AI Search, right? So in the metadata, I'll store the actual image as well, encoded in base 64 format, because it's much compressed format and it doesn't take a lot of space, right? So now when a user, let's say, asks a question like that contains like horse chewing a grass, it will take that we have the question from the user, it will convert that into embedding as well, and then search through the Azure AI search index that we have. And because we already have stored an image, the textual for that, it will match with that. And in the metadata, we have the original image as well. So I'll return that to the front end to the original user as well. So that's how it works.
Makes sense. Makes sense. So which model you have used to convert image into textual information?
That for that, I specifically I used GPT-4o for the front end to give me the final response. Again, also I used GPT-4o, but now recently GPT-5 was released, so I switched to that. To convert all my textual format into embeddings, I used the text ADA 002 model.
Makes sense. Why GPT-4 only?
Uh, so
Any
uh,
specific reason?
No, I test compared and tested with different kinds of model like GPT-4o. I also tested with GPT-4 Cloudy 3.5 Sonnet. But I saw the most improved accuracy with GPT-4o, and not only that, it is a little bit cheaper and much faster as well.
Sounds good. Sounds good. Your experience in the field of generative AI seems fantastic.
Mm-hmm.
Would you like to share your screen and go through Python coding test? One or two coding tests. Any Python.
Mm-hmm. Yeah, sure. Let me just quickly share my
You could
screen.
open any Python compiler. We will go through that. Just share your screen first
Mm-hmm.
and open any online Python compiler.
All right. Yeah. Can you see my screen?
Yeah, it's visible.
All right. Let me just type online Python compiler. Let's try this, and we can go for the first one. Yeah. Does this work?
Yeah, yeah, this is me.
Okay, sounds good. Yeah.
You could delete all those
Mm-hmm.
strings which are there.
Yeah.
Cool. So, would you like to write a code where I want to find the second largest number in the list
Okay.
without using any built-in method? You don't need to use any
Okay.
existing method. You just need to write everything from the scratch.
Okay. Sounds good. So just to confirm the questions, for example, if I have a list like let's say 5, 3, 2, 4, 1, so you need me to return 4, which is the second largest number in the list. Is that correct?
It's exactly.
Okay. And I can't use any inbuilt method, so I can't use like sort or get the max value or
Nothing,
anything, right?
nothing.
Okay. Sounds good. Yeah. So what I am thinking, just to like explain what my approach would be, I'm thinking I'll use some kind of a sorting algorithm to first sort this list, so it will become 1 2 3 4 5, and then I can just return the second largest element out of that, so that will give me the second largest number in the list, right?
Makes
So
sense.
for the sorting algorithm specifically, I'll use the bubble sort algorithm because it is easy to implement, it is much faster as well. So let's just try that. So bubble sort is basically how it works is, first we compare the first two elements, right? 5 3. If 5 is greater than 3, we'll switch it. So basically we are sorting the list, right? So this becomes 3 5. Then we compare the next two elements, that is 5 2. If it's greater, we'll switch it. So by the end, 5 will become the last number in this. So 5 is already fixed, and we continuously repeat this process 5 times, so it will basically sort the whole list together, 1 2 3 4 5. So that is how bubble
Makes
sort
sense.
works, right? So let me
Makes
just
sense.
do that. So I can either do it as a like in the ascending order, or the descending order, it doesn't matter. I'll just choose the descending order approach. Let's take the list. I'll go from from 4, because again our index starts from 0, so I have to go from 0 to 4, which is total 5 elements, right? So from 4 to 0, I'll go in a descending order. You can do it in ascending order as well, doesn't matter. And then let's say for j in range, I, right? So first, for example, I had to get this 4, this 5 to the last place. So I had to do this 5 times, right? 1, 2, 3, 4, 5. And then once 5 is fixed, we just have to then focus on the remaining 4 elements. So then the I will become 4, then 3, then 2, and 1. Right? So this is how it works. So I can just, I have to check if, let's say, my LST of J is greater than my next one. So for example, in this case, 5 is greater than 3, right? If I take the first two elements, then what I have to do, I have to just swap it. So 5 and 3, I'll comparing these and I'll swap it. So that becomes in uh, Python, I can directly do this. Plus 1 is equal to j. So I just swap the two variables. So then this becomes 3 5, and because initially it will do this 4 times, so then it will compare with this as well, the next two elements, and then 5 will come to the last place, right? And that should be it. And let's just print the value of my list and then run it. Yeah, so as you can see, now my list is sorted. So now what I can do is I can just get the second last value out of this list, and we get 4.
Could you please add zero anywhere in the list?
0, so I can do this as well. Yeah. Is that correct?
Yeah.
Yeah, it will still give
Nine
me
also. Nine also.
and 9. So if it is 9, then this should return 5 now, right?
Makes sense.
You can see 5.
Makes sense. Yeah. Perfect.
Mm-hmm.
Could you write one more question?
Mm-hmm. Yeah.
You need to count the frequency of a word in a string.
Okay.
So assume that I have given you a string.
Mm-hmm.
Uh, I live in India, comma.
Mm-hmm.
There is a comma after India,
Mm-hmm.
and after space, India is the best country.
Okay.
But right now the flaw over here is that I want the frequency of India to be a unique. So India comma should not a separate word and India should not be a separate word.
Okay. So India
India
should.
should be a single word.
Okay. So India should come 2 times, right? So for example,
Yes.
if I have, let's say, string, like, just the same example that you said. Let's say my uh, country's name is India, comma India, right? Say, and then full stop. So in this case, you want India to just come 1 time and not 2 times. Sorry, you want India to be appearing in the list 2 times. You want the count as 2,
Yes.
not India comma 1 and India. Okay, got it. Okay. Okay, so for this, what I can do is, first, my initial approach is, first let's split this list. Let's go one by one. So let's say for word in strng dot split, right? Let's see what the words are. Words. So you can see. Okay, so right now India comma and India dot are coming as separate words. So I need to fix that. So let's just fix it. So what I can do is I can do word dot strip. So strip basically strips anything which is of not of a whatever I put in this. For example, if I give dot, comma, exclamation mark, and question mark, so this will basically strip all of these characters from the words. So now if I run this, okay, so now India and India are coming as just one keyword. So now what I can do is I can store this in a dictionary, right? So I can create one example dictionary and check if the word is not in the dictionary that we created. That means it's coming for the first time. So what I can do is I can just initialize it, dictionary of word as 1. So that is, it means it's its first occurrence. Else that means that the word is already present in the list, right? So that means I can just increment it because it already has the value 1, then, or whatever the number of occurrence it has been till then, and I can just increment it by 1. So that should increase the value, and that should be it. So I can then print the dictionary that we have, and yeah, as you can see, now we have India 2 times and my country's name as well. Yeah.
Makes sense. Fantastic. Fair enough. You can stop sharing your screen.
Okay.
Next, we'll go through few of the machine learning based questions. So,
Uh-huh.
would you like to tell what is logistic regression and why we use the logistic regression?
Yeah. So logistic regression is a statistical model for classification problems, right? So it is similar to linear regression, but not exactly the same. So linear regression predicts continuous variables, so continuous values. For example, if you want to predict a price of a house, so that can range anywhere from between $10,000 to $500,000. But in logistic regression, we are predicting probabilities, which has to be between 0 and 1. So that is the main difference between linear regression and logistic regression. Also, logistic regression uses a function called sigmoid function, which basically brings the value down from continuous variables to between 0 and 1. So that is how it is different, yeah.
So, using the linear logistic regression,
Mhm.
can we do a binary class classification or we can also use for multi-class classification?
Yeah, so we can do both. It is possible to do single class classification as well as multi class classification as well. You can use approaches such as one versus all, right, where you can keep one class constant and try to predict all the other classes and things like that. Also, there is another special function called softmax function, through which you can do multi class classification instead of the sigmoid function, which does binary class classification.
Makes sense. Makes
Mhm.
sense. So, what is sigmoid? Do you have any idea on that?
Yes, so the sigmoid function is basically a function which maps any input number into a range from 0 to 1, right? So the formula for it specifically is basically 1 divided by 1 plus e raised to minus z, where z is our formula for linear regression, which is y is equal to mx plus c. So in this case, it's the same thing, mx plus c, where or beta 0 x1 plus beta 1 x2 plus the intercept variable. You can choose any of these notations. But yeah, it basically what it does is the function maps as I mentioned before as well, it maps the continuous variables from a linear regression between 0 and 1. Yeah.
Okay, sounds good.
Mm-hmm.
So, what are the metrics we can optimize the logistic regression? So, basically,
Mm-hmm.
uh, how logistic regression are getting optimized?
So do you mean the evaluation part?
Yes.
Yeah, so there are a few different ways to evaluate. You cannot evaluate the same way you evaluate a linear regression model, because, as I mentioned, in linear regression you can use MSE because it has continuous variables. But in logistic regression, we are predicting probabilities, because of which we have to use some different metrics. Some of the commonly used metrics are accuracy, but accuracy doesn't always work well in imbalanced data sets. That's why you can use more optimal evaluation metrics such as precision, recall. You can also use F1 score, which is basically the harmonic mean between precision and recall. So precision is basically you out of all the predictions that you made, how many of them did you get correct. Recall, the intuition is out of all the correct labels, how many did your model predict correctly. And then F1 score is the harmonic mean between these two, which is the best metric for classification problems. And then you can use also graph metrics, for example, ROC and AUC curve as well.
Sounds good.
Mhm.
Do you have any idea on log loss? What is log loss?
Yes, so log loss is what we use as a cost function in logistic regression. So as I mentioned, we cannot use MSE in logistic regression in classification problems. The main reason is because MSE is a non-convex function, right? So when we try to optimize it using algorithms such as gradient descent, there is a possibility that it can get stuck in a local minima. That is why for specifically for classification problems, logistic regression, we use log loss, or you can also say cross entropy loss, right? So the formula for and because it is a convex function, it can get to global minima as well. But yeah, the formula is basically minus y of I, where y of I is the true label, multiplied by the log of probability of y of I, right? And you take a sum across all classes and across all the records that you have. So that is basically the formula for log loss.
Sounds good.
Mhm.
Fair enough. How do you interpret the coefficients in logistic regression?
Yeah, so it is similar to how we interpret coefficients in linear regression, but here, because we are dealing with probabilities now. So what it basically means, like for example, in for one unit change in coefficient, what is the change in the probability of that particular variable, right? So that is in a sense what we mean by what the coefficients are.
Okay, makes sense. How do you choose the classification threshold? So basically, as you mentioned, we need to choose some threshold, and before the threshold, the class is zero and other class is one. So how do you usually choose that? What the number should be that before this the number should be become to the class one, and after that the number should become belong to the class two. So how do you choose that?
Yeah, so there are different kinds of ways that you can choose what the threshold should be. Usually, generally, people keep it as 0. 0.5. So if it is greater than 0. 0.5, you can classify it as 1. If it is less than 0. 0.5, you can classify it as 0. But this is not always the best case. It depends on the scenario that you're using the logistic classification for. But yeah, you can use, as I mentioned, the plot ROC curve, which is basically a plot between the true positive rate versus the false positive rate. And you can plot the value between different thresholds. For each threshold, what is the value that you're getting? And the higher the curve is, the higher your accuracy is basically for the model, right? So you can plot for different thresholds, you can plot this curve and check at which threshold you're getting the best value, and then you can choose that as your threshold. You can also use an alternative called precision recall curve as well, which is again similar. You plot different thresholds and just choose the one in which you get the highest value. But other than that, there are cases like there can be specific cases as well. For example, if you want to detect if someone has a heart condition or not, probability of heart failure or something like that, you probably want to keep the threshold a little low just to be on the safe side. And on the other side, for example, if you are flagging someone's email as spam, you do not always want to just keep spamming and irritating the user, so you can keep the threshold as high just to be really sure that this email is spam, and then only classify it as one. So it can depend on case to case as well. So yeah.
Makes sense. Would you like to tell me the you told that we need to draw a graph. So what type of graph, what the name of the graph we usually use to predict the threshold numbers?
As I mentioned, ROC and AOC curve. So ROC is
Okay.
basically what we plot between the true positive rate and the false positive rate at different thresholds. Right? True positive rate is basically the recall. Recall and true positive rate are the same thing. False positive rate is basically false positive divided by true positives plus false positives. So you draw a curve between these two variables across different thresholds, and the area under that curve is called AUC, area under the curve, right? And you want the area to be maximized because you want the true positive rate to be as high as possible, right? True positive versus the false positive rate to be as high as possible across different thresholds. So you want the area under the curve to be as large as possible as well. So usually, if your AOC is like 0.5, it's not working very well. It's just random guessing. But if it's close to 1, that means it's a good model. It's a much better model, perfect model, you can say. So, yeah.
Fair enough. Makes sense. One question, Nand. Why do we need to standardize or normalize the features which we are using to train our model before applying the logistic regression? So, do we need to do normalization or not? If yes, why so? If no, why so?
Yes, it is always recommended to use normalization or standardization because, for example, if your features are in different scales, for example, age can be in years, it can go from 0 to 100, right? And then, for example, you have a different feature like income or something like that, where it can be much higher number, right? It can be in 100,000, 200,000. So these are two on completely different scales. So what happens is when we are trying to fit the model, the coefficients, because the coefficients are separate for these two variables, it will assign higher values to higher variables, right? Because the scale of the variable, the income variable is much higher, it will start assigning higher weights to the coefficients, which is not completely right, right? So that because it's on completely different scales. So that's why it is important to like standardize it, making it on the much like similar scale, and then perform the logistic regression. Yeah.
Makes sense. Makes
Mhm.
sense. So, do you have any idea about imbalanced data set?
Yes, yes, yeah. So as I initially mentioned, right, if your data set is imbalanced, then it can be a problem. You can't rely on accuracy anymore, because, for example, let's say that we have 100 examples, right, and out of those 100 examples, 99% of the in 99 values, the true label is, let's say, one, and just one value we have zero as true label. So even if your model predicts like one all the time, 100% of the time, right, so it doesn't have any like variability, it just constantly gives the output as one. So in this case, the data in that data set, it will give 99% accuracy, even though that might not be the case, right, because it can have zero as well. So in this case, we can do a few different things. For example, for evaluation side, we can use different metrics. As I mentioned before, you can use precision recall, which focuses much more on the, for example, precision focuses on out of all the predictions that you made, how many of them are correct, right? So it doesn't depend on the whole data set, but on the actual predictions. And recall is basically out of all the actual labels, how many of them did the model get correctly. You can use F1, which is a combination of the two, and ROC AUC curve. So that is one thing. To mitigate the actual data set as well, you can do use a few techniques, for example, such as resampling the minority class, right? You can use algorithms such as SMOT to synthetically generate minority samples. And also you can adjust class weights as well, giving lower class to higher class to the one imbalanced ones. So yeah, you can use these techniques.
Sounds good. Sounds
Mm-hmm.
good. Sense. So, as we are discussing, can we use logistic regression uh, in the linear regression problem, non-linear relationships?
Okay, yeah. So that is a good question. So by default, itself, logistic regression is linear in the features. We have that assumption, but we can extend it. But similarly, as how we do it in linear regression, we can extend it by like you can add polynomial features, which makes it a little more linear. You can add more interaction terms, which is basically a combi. You can use a combination between different features and make the data set more linear. For example, if we have two features x1 x2, you can take a multiplication of that and use that as a third feature. So you can use that, those things as well. Other than that, you can also use kernel tricks, like although SVMs are better for this, but yeah, you can do all of this stuff to make it more linear.
Fair enough.
Mhm.
Is logistic regression still popular, even though, as must be aware about that, most of the advanced model like random forest or XGBoost, these are in the market.
Mhm.
So, is logistic regression still popular, or if it yes, why so, and if it no, then why so?
Yes, I think logistic regression is still a lot popular, and even though we have much better advanced models. For me personally, in my case, whenever I have a classification problem, I first use logistic regression just to get a baseline at least, and then I move on to other different models and compare and test. But yeah, the logistic regression is popular as well, mainly because number one, the interpretability of the model, right? So we have the coefficients which can be easily explained. We can get like the weights of the coefficients, and which feature is important, which feature is not, to get a feature impact and things like that. So that is one main reason. The other is the simplicity of the model. So logistic regression is very easy to understand. It is a very small model, so it doesn't take a lot of time to train. It is very fast as well. So that's why it is very simple to use. And as I mentioned, I always use it as my baseline performance because it is such easy to use, but still it works almost at par with the other advanced models as well. Not all the time, but yeah, it can perform much better as well in some cases. So that's why I always use it as my baseline performance. And it has a statistical foundation, right? So it is widely accepted in the community, in the in social, in the data science community, and it is easier to explain to the clients as well. So it has its like improvements in the business domains as well. So yeah, these are all the reasons why logistic regression is still relevant today.
Yes, yes. Just one last question.
Mhm.
How do you explain logistic regression to a non-technical person who don't know anything about this machine learning, data science, and everything?
Oh, okay, yeah, okay. Yeah, that is a great question. So, if I have a client which doesn't have any understanding or any technical understanding of any machine learning models or any data science models, what I can an example answer for me, like example could be this, right? So, I built a model that predicts the probability of an event happening. So that is the like the simplest explanation that we have in layman's terms, right? For example, whether a customer will buy a product, so each factor like the age, the income, the behavior, the browsing behavior of the customer adds or reduces to this probability. So all these different features basically impacts on the what the output probability will be. So the model doesn't just give me a yes or no, but instead it gives me a probability, like let's say 0. 0.8. So probability is always between 0 and 1. I'll just explain that. So I can say that 0. 0.8 is a high chance of this customer buying our product, and 0. 0.2 is a very like low chance that the customer will buy our product. So it will like 0. 0.8 I'll tell 80% chance, 0. 0.2 20% chance, right? Then based on our threshold that we set, for example let's say 0. 0.5, we decide whether to classify them as likely buyers or not. So for example, if there's an 80% chance it's greater than 0. 0.5, then we'll say okay, this buyer can buy the product and we can push more advertisement to this client, right? So that is how I'll explain to a basic non-technical person.
Makes sense. Makes sense. I think I'm good for my end, Susan.
Hmm.
So I hope I've covered everything what I need to.
Okay.
Thanks a lot, Susan. Thanks a lot for your time.
Yeah, yeah, thank you again so much for giving me this opportunity, and yeah, thank you.